All right, so it says to write two pairs of parametric equations. There's always like multiple ways you can write a parametric equation. So typically what I do is I start off by figuring out what I want x to equal. And the lamest, most boring possible way you could do this is to say that x equals t. And so if x equals t, then you would say y equals 1 minus t squared. That's why that's boring, because it's just straightforward. It's just like direct substitution. So that is one possible parametric equation you could have, where you would have x and y separately defined in terms of t. Another possible parametric equation you could have is you could say x equals the square root of t. And if that was the case, then what would y be? 1 minus t. A third option is you could say x equals t plus 2. And then what would y be? Yep. So whenever you want to write a parametric equation, you always have lots and lots of options, okay? I'm going to say I want you guys to write your own. So do an option 4 and then come up with one. Yeah. They can be anything you want. Yeah. Which is why I was saying this one is like the laziest one. Because you're literally just like, yep, directly substituted in for x. X equals t, that's the boring one. With parametric, we always do it in terms of t. So it has to be a t.
Is there a way to make it not exist?
You could probably mess with the problem and ruin the domain in some way and make it so there would be an issue. Maybe don't shoot yourself in the foot like that, but otherwise. Well, and if you think about it, technically I kind of did that with this one. Like, this one would be defined for all real numbers for t, but this one would only work for anything greater than 0. Because I put the square root in there. Yeah. All right, so let x equal any function of t. And then after you figure out what the x is, then you can figure out what the y is by plugging that in for the x. I guess, yeah. That might be a shoot yourself in the foot sort of situation. All right, example 8. So we're going to do the same thing again, but with a new scenario. So first, if we said x equals t, then y would be what? Okay. What if we said x equals 2t? Yeah, 4t squared, or you could say 2t in parentheses squared. What's another one we could do? T squared. And then y would be 1 over t to the 4th. Okay. All right, so here we're going to consider the parametric equation x equals 8 cos t and y equals 8 sine t. So one thing that we're going to remember is the Pythagorean identity that has to do with sine and cos. Do you guys remember what that is?
Cos squared plus.
Okay, so cos squared t plus sine squared t equals 1. Okay, so what we're going to do is we're going to use this to kind of do some substitutions into this, okay, and see if we can come up with another equation. So I'm going to write what that squared actually means. It really means that you're taking cos of t and then you're squaring it. A lot of people forget that's what it means. This one means you're taking sine of t and then you're squaring it. So that means that for these up here, I have to solve for cos of t so that I can substitute it in here. And I have to solve for sine of t so I can substitute it in here. Okay? So if I have x equals 8 cos t, then what should I do? Divide by 8. So x over 8 equals cos t. So that makes this x over 8 squared. All right, and then for the other one, we're going to say y equals 8 sine t. And so then what do I do? Y over 8. So if I simplify this, I would think of that did not become a y. That's still an x. I would think of that as x squared over 64 plus y squared over 64 equals 1. Anyone know what that's the equation of? It's a circle, yeah. So this is the same thing as x squared plus y squared equals 64. So it's a circle centered at 0, 0 with a radius of 8. Okay. Now I could graph this, right? Centered at 0, 0 with a radius of 8, and I could graph a circle, but what would be missing from the parametric equation? The direction, yeah, the arrows. Does that make sense? Okay, so let's go ahead and graph it parametrically. So I'm going to think of my t values and what my resulting x values and what my resulting y values are. So my t values are going to be something that I'm doing cos of or sine of. So I'm picturing the unit circle. What are easy numbers to plug in for cos and sine that would be easy to graph? 0, pi, pi halves, 3 pi halves. So I'm going to say let's start with 0 and then let's try pi halves and pi. All right. So 8 times cos of 0 is 8. 8 times sine of 0 is 0. So that gives us the point 8, 0. That's where we're starting. 8 times cos of pi halves, 0. 8 times sine of pi halves is 8. Okay. So it went from here to here. And I know the arrow goes this way. And then pi, so if we have 8 times cos of pi, negative 8. And then 8 times sine of pi, 0. So negative 8 zeros right here. There's our arrow. Do we need to keep filling out the table? Probably not. We can probably just finish it. I was trying really hard. But the one that I drew on my better copy of my notes, look at how good that one was. Last year's Miss Rice was so much better. Goodness. Okay, you guys still drawing? It takes a lot of focus to draw a circle.
I'm not even trying because I had to freehand graph in the first place.
Oh.
Yes, so did I.
Not gonna.
I'm sorry. I could have printed one for you. I'm sorry.
Good. It's good, but I'm not going to join in this circle.
Perfect circle
length
comparison. Yeah. All right. So part B says, how does the curve represented by these parametric equations, so x equals 8 cos t plus 3, y equals 8 sine t plus 6, how does that compare to the original curve? all we're going to do is we're going to convert it into rectangular, and we're going to see what the differences are, okay? So just like before, we're going to do the same thing where we're going to look for cos t squared plus sine t squared equals 1, and we're going to make our substitutions. So for this one, I'm going to say x minus 3 equals 8 cos t. And then what should I do? Divide by 8. So that means that I'm going to have x minus 3 over 8 squared. And then I'll have y minus 6 equals 8 sine t. And then again, I'll divide by 8. So can you tell what that did? Yeah, it moved to the center. So we're going to have x minus 3 squared over 64, y minus 6 squared over 64. All right, so what did it do? Shifted up 6 into the right 3. Okay, so it shifted right 3, up 6. Okay, or looking here, we could say right 3, up 6. The radius stayed the same though. Okay. Okay, so the next question says, how would the original curve change if the cosine and the sine were switched? So instead of having x equals 8 cos t, if we had x equals 8 sine t, and y equals 8 cos t, if we did it that way. So what we're going to do is we're going to write a table so we can think about what would have happened. So if we plug 0 in for t, x would be 8 times sine of 0, which is 0, right? And then 8 times cos of 0 would be 8. We know it would look the same, right? Because it'd still be a circle, it'd still be centered at 0, 0, it'd still have a radius of 8, yeah? 8 times sine of pi halves is 8. 8 times cos of pi halves, 0. Okay, so where would it have started? 0, 8. So it would have started up on the y-axis, up here, and then which direction would it have gone? Yeah. So the other one started at the positive x-axis and went counterclockwise. This one starts at the positive y-axis and goes clockwise. So for rectangular coordinates, it would look exactly the same. But for a polar, or not polar, for a parametric equation, we would see that, that the orientation has changed, so the direction has changed, okay?